Alright, so we're going to look at the unit circle here. And just to give you a context, this is just on graphing paper if we had zoomed way in, and this is one square right here. So this is a distance of 1, and the radius of that circle then is 1. So that's why they call this the unit circle. So we're going to do some folding activities with this. You might want to get a straight edge to draw some lines. And first fold we'll do is just to get those two crosshairs lined up. And then we can see how that makes an intersection there with the edge of the circle and here. Okay. Our next fold, we're going to fold the top of the circle in half by putting that crosshair right here and folding, and then open it back up, and you can see that this has now made another crease, and that line intersects over there. Okay, so now let's go ahead and draw a straight line like so. Okay, now what I'd like to know is what is the coordinate of that point? Okay, do you know anything about the location of that point? Well, I know something about the height because all the way up would have been 1, but remember we folded it in half, and so the height of that point is at 1/2. That means the y is 1/2. Now to find the rest, here we go. We'll go ahead and just make a triangle here. Okay. And we've dropped a line that's perpendicular to the x-axis, so we have a right triangle, and we can use Pythagorean theorem. I'm going to pull this out and try and roughly imitate it here on some just regular paper. So we know that the height is 1/2, and remember that this hypotenuse is a radius of the circle. So that means that it is 1. And we need to figure out what x is. So I know the Pythagorean theorem is going to say x squared plus 1/2 squared equals 1 squared. And solving that, I get x squared plus 1/4 equals 1. And then x squared is equal to 3/4. And I take the square root. Remember, if you put the square root on there, you have to put plus or minus. We get x equals plus or minus the square root of 3 over 2. So if x is equal to the square root of 3 over 2, that means that this distance here is square root 3 over 2. And of course it's the positive one because we went to the right. Okay, now the negative square root 3 over 2, well, that occurs over here where I've got another intersection point to the circle. Okay, and you'll notice it's the same triangle, it's just been flipped over the y-axis, and so that gives us this negative square root of 3 over 2 comma 1/2. It's the same height as this other one, and then we have the same distance from 0, but we went to the left, so it's a negative square root 3 over 2. Okay, let's go ahead and make another fold. I'm going to take this and fold it here and open that up, and you'll see we have this crease is intersecting with the circle right here. Okay, remember we have the radius of the circle right here as 1. Again, I want to know what the coordinate of that point is. So how did we get there? Well, I do know that this distance here is 1/2 because this is 1 and we folded it in half. So it was right 1/2 and then up. So right 1/2 and then up. And so let's go ahead and imitate that on another piece of paper here. This rough sketch here. It's a right triangle. I know this is 1/2 and I don't know what this is, but I know that my radius is 1. So I'm going to again use the Pythagorean theorem and solve for y. You notice this seems familiar. We just did this with the x. So y is now plus or minus the square root of 3 over 2. And that makes sense. So this is really the same triangle as what we had before. It's just been turned in a different way, kind of this way. Okay, so this is going to be the square root of 3 over 2. Now, again, we had this where it could be a positive or a negative square root 3 over 2. Well, that point is down here. It's a negative square root 3 over 2 down there. And the x is the same. We went to the right 1/2. Okay. Now we can do another fold. Let's go ahead and put these two cross marks on these two cross marks. So we're folding it perfectly diagonally. Okay. Corner to corner. Open that up. And you can see we have once again intersected with that fold on the unit circle. All right, let's go ahead and draw our radius in. And again, our goal is that we want to find what the coordinate of that point is. Well, let's follow suit like we did the other two triangles. Drop that down. So right angle there. Okay. And let's imitate this again on some paper. So we have these two sides and this hypotenuse. Okay. And the only thing that we know for sure is that this is 1. But we also know that the sides are equal. This side is equal to this equal. The legs of the triangle are equal. So I have an x and a y. So x squared plus y squared equals 1 squared. But x is equal to y. So what I could do is replace that y with an x. Okay. So that gives me 2 of those x squareds equals 1. X squared equals 1/2. And now I'm going to take the square root. Remember your plus minus both sides. So x is plus or minus 1 over the square root of 2, which we're going to rationalize by multiplying by square root of 2 over square root of 2. So x is plus minus the square root of 2 over 2. And since y is the same measure as x, then y is also square root of 2 over 2. So when I come back over here, I have the square root of 2 over 2 and the square root of 2 over 2. And where are we going to have the negative of that? Well, we can have that over here. If we fold our circle this way, then we're going to have those same coordinates that are over here. The only thing that changes about those is that this is positive square root 2 over 2 and negative square root 2 over 2 because we had to move down on that y-axis. Over here we have the negative square root 2 over 2, positive square root 2 over 2. Over here we have negative square root 2 over 2 and negative square root 2 over 2. Okay. So lots of measurements getting filled in here. You know, you can fold up from the bottom, and again, we get those intersections here. You can go through that same process of finding them, but what you're going to notice is that this has a coordinate square root 3 over 2, 1/2. This one's also going to be square root 3 over 2, 1/2, except that the y is going to be negative. Okay, and go ahead and fill the other angles in. Again, you can fold here, and that's how we're getting all of the places on the unit circle that give you the special angles. Okay, and when we look at this, we can think of the values for x and y as being the cosine sine. So whenever we're looking at whatever angle this is, we know that it is the cosine of it is going to be square root 3 over 2. And then here, the sine of this angle is, look at the y part, square root 2 over 2, and so on. And of course these, 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay, now I want to talk about getting those different denominations of the angles, because that's what's going to help you, is to be able to picture in your mind what's going on here. Okay, so first I want you to go over 1/2 and then just go straight up until you hit the circle. Drop a dot. Over here, go left 1/2 and then go straight up until you hit the unit circle and drop that dot. Okay, let's get a line drawn across here, and then there, and there. Okay, so we're looking at just the top half of this. Now we'll talk about what the circumference is. The circumference of this unit circle, well, the circumference of any circle is pi times the diameter. So the circumference here is pi times, well, we have 1 here and 1 here, so the diameter is 2. Okay, so our circumference is 2 pi. That would be the distance you would have to travel around to get back to where you started. Okay, about 6.28 units, whatever kind of units you're using. All right, now what I want to do is talk about just that top half of the circle. If I'm only just talking about the top half of that circle, that is 1 pi. Okay, 1 pi. What we've done by going to the right half and up, to the left half and up, is we've divided that top part of this circle, that 1 pi, into 3 equal pieces. So if this is pi to get over here, this is pi over 3 to get to there. And then you can count by that as you go around. Pi over 3, a 2 pi over 3, a 3 pi over 3, which we know is pi. So 3 pi over 3, and we're going to go down here and do the same type of thing over there. Okay, so pi, this is 3 pi over 3, this is 4 pi over 3, this is 5 pi over 3, and this is 6 pi over 3. 6 pi over 3 is 2 pi. So when you're thinking about getting to pi over 3, what you really want to be picturing in your mind is I had to go to the right half and then up. That must mean that the cosine of pi over 3 is 1/2. Okay, looking back at the unit circle that we had, this is pi over 3, and we see the cosine is indeed 1/2. Okay. Now the next denomination of the unit circle that I want to do would be by going up 1/2 and then straight horizontally over until you hit the edge of that circle. Okay. Right. And again, we can draw a horizontal line here, going through there. Again, up 1/2 and over, and we get this over here. And I'm going to go ahead and draw in the pi over 3's that I had. And you'll notice as I draw through, drawing through up on the y-axis as well, we have divided that pi, the top half of that circle, into 6 equal pieces. So I have pi over 6. I have 2 pi over 6, right, which I know is pi over 3. I have 3 pi over 6, which I know is pi over 2. I have 4 pi over 6, which is 2 pi over 3. I have 5 pi over 6, and I have 6 pi over 6, which is pi. And you can continue these measurements down here. Okay, you can just estimate them. You may not be having a ruler with you everywhere you take a quiz or a test, but we're just thinking about, counting by pi over 6 as we go. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, which I know is 4 pi over 3, 9 pi over 6, which I know is 3 pi over 2, 10 pi over 6, which I know is 5 pi over 3. I've got 11 pi over 6 and 12 pi over 6, which is 2 pi. Okay, now the thing that helps with this is that you can see here's your pi over 6 angle right there. Well, 7 pi over 6 is the same angle away from the x-axis. It lands over here, but when you look at your unit circle, once you get all of your angles filled in, this has a coordinate of square root 3 over 2 comma 1/2. This will also have a coordinate of square root 3 over 2 1/2, except that the x is going to be negative and also the y is going to be negative because we're in this coordinate. So this is the reference angle. Pi over 6 is the reference angle for 7 pi over 6. Again, 11 pi over 6, it just takes one more pi over 6 to get back to the x-axis. So pi over 6 is the reference angle for 11 pi over 6. That means its coordinate is also going to be square root 3 over 2 comma 1/2, except that the y is going to be negative because we had to go down to get to that point there. 5 pi over 6, it takes just one more pi over 6 to get to the x-axis. So its reference angle is pi over 6. So its coordinate is going to be square root 3 over 2 1/2, except that the x is negative because we had to go to the left to be able to get to that point. Okay, so we have one more denomination of unit circle, and that's where we have folded it diagonally, and I'm going to attempt here just to draw this in. Okay, so we're going like this. Okay. Right. So again, just thinking about the top half of this circle is 1 pi. Okay, this is 1 pi. And we have divided this up into fourths. So this is pi over 4, 1 pi over 4, 2 pi over 4, which is pi over 2. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, which is pi, 5 pi over 4, 6 pi over 4, which is 3 pi over 2, 7 pi over 4, and 8 pi over 4, which is 2 pi. And this is probably the easiest angle to do because all of these are going to have coordinate of square root 2 over 2, comma square root 2 over 2, and it just depends on which quadrant that you're in as to what's going to be negative there. You'll notice everything in this quadrant is plus plus. Everything over here is going to be negative positive. Everything over here is going to be negative negative, and everything over here is going to be positive negative.